Hi, I'm Fernando Pereira from UFMG Brazil, and today we shall talk about different live range splitting strategies that we can use to implement sparse data flow analysis. First, let's review the special instructions that we use to split live ranges. We have seen three kinds of instructions: the Phi-Functions that exist in SSA form programs, plus the parallel copies and sigma functions that we saw in the last class. Parallel copies are just a notation used to split live ranges. They indicate that we should read all the variables on the right side and copy them in parallel to the variables on the left side. We indicate them with the double bars, and we use them to split live ranges in the middle of basic blocks. Phi-functions, in a sense, are multiple parallel copies inserted in the beginning of a basic blocks that have multiple predecessors. So if we have n Phi-functions in a basic block, and each one has k arguments, then we have k parallel copies, each one copying any variables. Sigma functions are the opposite of Phi-functions. They exist at the end of basic blocks with multiple successors, and they also represent multiple parallel copies. So if we have any sigma functions at the end of some basic block, and they define vectors with k elements, then we have k parallel copies, each one copying any variables. You might stop the program and think about the figure that we have on the right side to understand what's a sigma function. The way that we use live range splitting to sparsify certain static analysis is called a live range splitting strategy. A live range splitting strategy is formed by pairs. Each pair consists of a program point, where live range must be split, plus a direction indicating if information flows forward or backward along the control flow graph. For instance, in this example about class Inference, can you figure out what's the live range splitting strategy? We split live ranges at the places where methods are invoked on objects, and information flows backward. In this case, we have three program points, L4, L6, and L7, all associated with the up arrow, which indicates that information flows in the opposite direction of the control flow graph. Could you think now about how would be the live range splitting strategy for null pointer analysis? Try to think about how information appears in the analysis and how it propagates. We had seen that in this case, information appears on the uses, that is, when methods are invoked onto objects, and also at the places where objects are instantiated. And this information moves forwardly along the CFG. So we have point L1, where V is instantiated, and points L2, L3, and L4, where V is used. And the arrow is down, meaning forward propagation. Now, can you think about our tainted flow analysis? What would be the live range splitting strategy? Remember, we have information flowing forwardly. New data flow facts appear at definition points and at branches that test variables, if they are clean or tainted. Here's the live range splitting strategy for the example program. We have two definition sites and one sanitizer, that is, a branch that tests if a variable is clean. And we have the arrow down indicating the forward propagation. Now let's talk about constant propagation once again. What would be a live range splitting strategy for constant propagation? You can stop the video and look at the program to have ideas, and then you can think about this question. There are two main implementations of a constant propagation. The simplest, which we have already seen, only takes new information at definition sites. In this case, we have the live range splitting strategy that produces SSA form. But there is a paper from Wegman and Zadek from 1991 where we can learn information also at conditionals that compare something with a constant. In this case, we have also information appearing at branches, and it propagates forwardly. So we have the same splitting strategy as the tainted flow analysis if you follow Wegman's paper. And with this last example, we close this class that has introduced the notion of live range splitting strategy. Next time, we shall see how we can implement the live range splitting strategy. Thank you.